Okay, I wanted to share with you a little bit more here about the graphing the parabolas and finding different things on these parabolas. What I've got here, y equals ax squared, of course a being the positive, so it's opening up here. On these parabolas, we've got several different things. Of course, they'll want to for us to find the vertex, and of course these aren't shifted away from 0, 0, so our vertex, the point right here on these that haven't been shifted at all, their vertex will be 0, 0. So on this one we do have a vertex of 0, 0. They'll also want our axis or axis of symmetry, which is the line that is right through the middle, and so of course in this case it's the line that's right on the y-axis, or is the y-axis, which is a vertical line, which always is x equals a number. A vertical line is x equals a number. In this case, the x would equal 0, and so that's our axis of symmetry. They'll also want us to talk about the focus, find the focus. And the way I do that, different ways of doing it, but the way I do it is the distance to the focus from the vertex is p, and so I have a little formula here. It's p equals 1 over 4a, where the a is what's times x squared, y equals ax squared, so 1 over 4a, that's our p distance. And in this case it's along the axis of symmetry, and so yeah, there's our focus. Of course it'll be right on the y-axis, so that's 0, comma p will be the focus for those that aren't any kind of shift on it. Now, another one that I don't think I've mentioned yet is a line that's called the Directrix. And what the Directrix is a line perpendicular to the axis of symmetry, and it's actually going to be kind of below your, in this case, below the parabola. And turns out that so it's perpendicular to the axis of symmetry, and it turns out this distance right here from the vertex down to the line is it's negative p. It's the opposite of whatever you find p here is. And so in this case we've got a horizontal line, which is always y equals this Directrix, and in this case it's down p minus p units. So that's what is known as Directrix. Now, on the second parabola I have here, of course our vertex, it's a sideways parabola because we've got x equals ay squared. And so anyway, that has a vertex of 0, 0. And our axis of symmetry, well, our axis of symmetry is a horizontal line, which is always y equals a number. And so our axis of symmetry here is y equals 0. And the focus, still p equals 1 over 4a is one way to do it. But the p then is here. This distance is p right there. So that would make the focus It'd be on the x-axis, so that'd be p comma 0 is your focus. And the directrix, well, it's again perpendicular to the axis of symmetry, kind of on the other side of your parabola. And so in this case, running perpendicular to the axis of symmetry means it's a vertical line, which is x equals a number. And again, it's always the opposite p, the negative p distance away is where your directrix is. And so that's how we find those things when it asks. All right, so let me come over here to one of the homework problems. And it says find the vertex, axis of symmetry, x-intercept, y-intercept, focus, directrix. And our parabola is x equals 1/7 y squared. X equals 1/7 y squared. All right, and so that's, we've got the x equals something y squared, and so we know that's one of the sideways parabolas. Just kind of sketch, give it a rough sketch here. So it's a sideways parabola, openings to the right there. And so our vertex, well, that's 0, 0. 0, 0 for our vertex. Zero, comma, 0. Whoops. There, the wrong way. 0, comma, 0. All right. Got that one. The axis of symmetry. Well, it's the axis of symmetry over here is running right through the middle of the parabola there, and so that's a horizontal line, which is y equals a number. In this case, the y equals 0. So our axis of symmetry, y equals 0. Y equals 0. All right. X-intercept, well, as always before, find the x-intercept. We set y to be 0. So we get x equals 1/7 times 0 squared, which is 1/7 times 0 is 0. And so our x-intercept would be 0, 0. And it's going to ask for the y-intercept there as well. So let me go ahead and compute that. The y-intercept, we set x to be 0. So we have 1/7 y squared. 0 equals 1/7 y squared, setting the x to be 0. And of course, multiply by 7, you still have 0 equals y squared. Square root both sides, and so the y-intercept is also 0. Both the x and the y-intercept. You could look at the graph too, I guess, and see that, but both of those are 0, 0 as well. 0, comma 0. And y-intercept, yeah, y-intercept 0, comma 0 as well. All right. Focus. All right. So come over here and talk about our focus. The focus, I like to compute it as 1/4a. And so in this case, a here is 1/7. What's times the y squared? And so that'd be 1 over 4 times 1/7. 4 times 1/7 is 4/7, so that'd be 1 over 4/7, or 1 divided by 4/7, which is 1 times the reciprocal, 7/4, so that would be 7/4. So the p distance is 7/4. It's along the axis of symmetry. And so that puts our focus there. If that's 7/4 of the way, that would be 7/4, comma 0 right on the x-axis. So that's our focus they would want. So let's put that in. 7/4. 7/4, comma 0. All right, what's that? The directrix. Okay, so as we were saying, the directrix then is the line that's opposite over here on the other side of from your focus, and it is minus p that away. Now it's it is a vertical line, and so that's x equals a number, and if it's minus p, p is 7/4, so minus p would be minus 7/4. So our directrix is at x equals minus 7/4 is the way they would want us to type that in. X equals a negative 7/4. All right. Okay, now, as far as graphing it here on the graph, you have to be a little selective. What they, of course, want you to do is, first of all, start with the vertex here. Let's see if I can get this a little bigger. All right, and so on our palette here, we've got a selection. Of course, we know it's a sideways parabola, and so that's the fifth one over here from the left. Okay, and like I said, you start with the vertex. Let me clear that off. I didn't quite get it at the right spot. All right, so we start here right at the vertex, 0, 0. And then they're going to want one other point. Well, to get this other point, scroll down just a little bit. Maybe get a new page here. And so we've got x equals 1/7 x squared. And so we need to come up with a nice clean point, and by that I mean one that has integer values, no fractions or anything, because it won't really allow me to do fractions over there. And so looking at this this equation, if I since that's a 7 denominator there, if I pick y squared, I'm going to square the y and basically divide it by 7. What if I picked y to be 7 here? So that makes x equals 1/7 times 49. Well, of course, that has a nice value. 1/7 of 49 is 7. So we get, when x is 7, we get, nicely enough, y is 7, so we get the point 7, 7. And I think that will be an easy value to, I think, maybe put in over here, 7, comma 7. Nope, messed it up, okay. Let's try again. All right, so 0, 0. And if I mess up, it'll really... Okay, so 7, 0, 0, and then 7, 7, 7. Okay. All right, and so that's how you go through that one. Now, I want to show you another one here. Yeah, on this second one, we've got negative 6x is equal to y squared. Let me get another page here. X equals, negative 6x equals y squared. And we do want to graph that one here, first of all, it says. And what I want to show you there, a good point on that one, we do know, well, first of all, if I divide by negative 6, y squared over negative 6, which is negative 1/6 y squared. And so that one, we've got x equals ay squared, but it's negative, and so real roughly, that's going to be a parabola that opens to the left. And our vertex is at 0, 0, which that'll be our first point we graph over there. But what I was going to show you over here, on these, if you've got it in this format here, what if we choose x here to be negative 6? X is negative 6. Then we have negative 6 times negative 6 equals y squared. That gives me a positive 36, which is going to give me a nice other point to graph over here, because you square root that, you got positive 6 and negative 6 for the y. And so what we've got for another point here is we've got x is negative 6, and then the y is positive 6 or negative 6, either one. And so that's going to be our other, so we're going to go to negative 6 and positive 6, and that's going to be our other point besides the vertex there on our graph. So we've got 0, 0. We've got to select the sideways parabola. And then 6, 0, 0, and then negative 6, positive 6, right there. And so that should get us, yeah, all right. Now this one too, we also wanted domain and range, getting back to that. The domain are the x values here. Well, the x values do go from 0 out to negative infinity, actually negative infinity to 0 is how we would write that. Negative infinity, comma, 0. So get us to recall that. Oh, and actually 0 is included, so we'd need a bracket on the 0. Then the range, well, the y values, this keeps headed up on this side and down on this side, so the y values are going to be all real numbers, negative infinity, positive infinity, is how those sideways parabolas will turn out. So that one gets us to recall a little bit about the domain and range, which is not a bad thing to do. All right.